Swayam Prabha. Digital India. Educated India.
Hello everybody, a very good morning, good afternoon, good evening to all my dear friends and the students who have taken this TQM on course number 1, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are going to start the 12th lecture. As you know, till the 11th lecture we were discussing about, before that, the concept of Kaizen and the fishbone diagram, cause effect analysis. Then we went into the 7 tools of statistical process control. We considered how the Pareto concepts could be utilized. So, we will continue on that and obviously build up. As I said, there would be a detailed discussion about the different type of charts like X bar and R charts, P charts would be considered in a separate mode in details. So, continuing with the 7 new tools of quality control. In 1976, the Union of Japanese Scientists and Engineers collected and promoted the ideas and the concept of 7 management and planning tools. So, these tools and the emphasis of these tools were in the following areas and how the concept could be utilized. One is basically the affinity diagram, and it will give you the core idea, so called not directly, but definitely what are the cause and effect and how these things can be analyzed. If you remember in the scatter plot, I did mention though fleetingly that you can find out excellent diagrams, excellent analysis using histograms and all this concept, but what is the actual relationship between the actual causes and its effect have to be analyzed both from the mathematical and statistical point of view as well as from the qualitative point of view, that you will try to analyze actually whether those cause and effect or the relationship between say for example humidity and quality, if those we are interested to study actually make sense, and whether we can utilize all the tools and the techniques in order to understand what are the effects and how they can be reduced, like variability can be reduced, quality improvement can be done, cost can be reduced and all these things. So, continuing with the 7 tools for quality tools for quality control, one is the affinity diagram, then you have the relationship diagram, then you have the tree diagram, the matrix diagram and the matrix data analysis. So, beyond general course I will just discuss as they are important. So, often it is replaced by prioritizing the matrix due to the complex mathematical relationship which may happen between the cause and effect. And you may be able to utilize different type of brainstorming session, different type of Pareto charts, different type of quality control charts in order to make a simplistic viewpoint of how matrix data analysis can be utilized. And continuing with the matrix data analysis, a prioritization matrix in a L-shaped matrix should be utilized in a pairwise comparisons like case cause 1 and cause 2 or say for example x and y. You want to understand what is the relationship and how it affects the overall quality in the whole scheme of things. So, they uses pairwise comparison of a list of options to select the criteria, and obviously you can utilize different type of non-parametric optimization tools which we are not going to discuss here, but I will just mention like AHP, TOPSIS, Electra and all this process can be utilized to find out the priorities based on which you can proceed to understand the overall cause and effect in a much better way. So, I am not saying this is the only way, there are other methods also, but these are very heavily utilized when the overall feedback which you are getting for the process, for the system, for the services may not be quantifiable. So, such that you use some conceptual and qualitative feel that how they can be modeled. Then the last 2 tools under the new tools for quality control are the arrow diagram, the process decision and the program charts. So, in the affinity diagram, so also known as the affinity charts, so they are known as the so called the KG method of variations. What are those? I will just briefly mention them. When to use is that after you have done a brainstorming session, like say for example, there are issues of cost, issues of quality, humidity is a problem, temperature is a problem, cutting tool is a problem, or the coolant which is being utilized for different type of CNC machines are a problem. So, if this is a problem, the shop floor manager, the workers, the engineers, the design engineers, the purchase manager, the vendor, they sit down together, do a brainstorming session, try to find out what are maybe the causes and try to basically go into the depth, do cause and effect analysis and try to find out the actual bullet points based on which some analysis and some actions can be taken. So, when they are basically used when analyzing verbal data such as survey which has been used, where you would not get any quantitative feedback such that it is easily explainable to all the people who are in part and parcel of the decision making process. So, you have done a data, you have got some informations and those are qualitative in nature. You want to basically get the feedback on the qualitative sense from different stakeholders who are there in the process. As I mentioned the stakeholders, so and based on that you try to collate the data and get the best so called set of information from them. So, how to create one affinity diagram? So, record each idea with a marking pen on a separate stick note or a card. So, whatever the idea is that you have a board, you continue sticking the information set or the ideas which are coming out from different players. So, they may be random ideas which may not be directly related to the problem which you are facing. They can be, say for example, if the product is bad, information or the workers may stick, say for example, some information related to the vendor issue, may be related to the humidity, may be due to the temperature which is there, maybe say for example, the food quality is not good, whatever it is. You write down in stick notes, stick them, and then from there when all the ideas are there. So, ideas should be coming out without any hesitation from all the stakeholders. Obviously, they would be there would be ideas which will be diametrically opposite, people may not agree, but at least encourage and have all the ideas coming out from the discussion and make a collation of them. Look for ideas that seems to be related in some way and place them by the side such that now it is makes a logical sense that all the ideas which you have got, all the brainstorming sessions which you have done with the players basically are now making sense as you basically collate and make a logical sequence or logical flow or a logical idea that how they are related to each other. And these ideas can be grouped into different categories, maybe some are more related to say for example, technical issues, some may be related to say for example, environment issues, some may be related to say for example, vendor issues. So, collect them in separate groups. So, when ideas are grouped, select a heading for each group, what you think are the important points and try to basically prioritize them and put some amount of importance on them. Look for a note in each group that captures the meaning of the group. So, say for example, it is related to the environment may be say for example, what is coming out may be too much of humidity or maybe say for example, too much of temperature increase in the environment where the machines are being utilized, or maybe say for example, there is a issue of raw materials not being of same quality. Say for example, the issue may be related to the vendor, but once you basically dig deeper into the problem, it may come out that the raw materials which you are getting is actually an issue which the vendor also does not have any control. So, it may be that you may have to change the vendor. So, rather than blaming only the vendor, try to find out what are the actual set of groups which are important, and from that basically they get one main idea out of the focus idea on which you can concentrate in order to basically tackle the problem. Combine the groups into super groups if appropriate and then try to find out what is the linkage flow of all these subgroups such that they give you a logical sequence how you tackle the whole problem. So, an application of statistical probability control would be say for example, you are trying to find out some problems which you are getting from in the area of measurements. So, it may be that percentage of purity is a problem, percentage of trace metals which are there is a problem, maintenance cost is very high. Then it may be number of emergency jobs which has to be done is an issue. It can be say for example, the amount of product which is produced is an issue. It may be the amount of raw materials or wastage which is done is an issue. It can be say for example, if you are trying to basically use some coolant, then viscosity of the coolant is an issue. rate of flow of the coolant is an issue, or maybe what are the jigs and fixtures you are trying to utilize may be an issue. So, all these things are basically noted down. And once, so in the leftmost diagram, these two columns in the chart which is there on the slide, it basically gives you the, after the brainstorming sessions, what are the affinity diagrams or the affinities concept which you have got, the bullet points or the groups which you have got, they are noted down. And once they are noted down, they are basically grouped into subgroups such that you have a clear cut idea that what are the important main headings you have to basically analyze or where you have to concentrate. So, what this is an example, you can basically, some people who work in the factory or who have done all these things would be aware. So, what you do is that from this you get the affinity diagram and you have basically the main headings which is coming out. If you consider the bullet points here, one is related to the product quality where I am pointing my pen, one is the product quality, one is the maintenance concept. So, under maintenance you have the maintenance cost, the number of emergency jobs you have to done, number of pumps and seals for these failures. For this example, it can be, say for example, hours of downtime, service factors, percentage of uptime, time between turnouts, or on how frequently the maintenance work is done. So, all these are related to maintenance, hence maintenance is one of the main key bullet points on which you have to basically concentrate. Others in this whole example are, one is the product quality, it may relate to color, viscosity, parts per million which is being utilized, it can be number of customer returns or the feedback from the customers which are negative. So, they are under product quality. Another can be, say for example, the manufacturing and the manufacturing cost, they may be maintenance cost, material cost, the utility cost, and the hours of employment, the overtime which you are giving, and all these things which are there. Other issues can be safety and environment, it may be due to housekeeping, how the housekeeping has been done, the environmental, the how is the temperature, what is the humidity, what is the wastage amount, and so on and so forth. Another may be, say for example, volume, and so on and so forth you can have, such that you understand that all the ideas which have come out from the brainstorming session can be basically clubbed into groups, such that the groups when combined gives you the overall idea where the problem lies. In the relationship diagram shows cause and effect relationship. So, it is exactly like in concept wise is like the fishbone diagram which we have discussed. So, it gives you the cause and effect relationship and to what degree which is the relationship holds. When to use the relationship diagram is a question. So, when trying to understand links between ideas or causes or cause and effect relationship, we need to use the relations diagram. When a complex solution is being implemented, then the overall relationship between different elements becomes complicated. So, hence you what you do is that you try to basically find out what is the overall linkages between different important points in the cause effect diagram, such that you find out what is the linkages between them. You also use relations diagram after generating an affinity diagram or cause and effect diagram, such that it gives you. So, if you go back to the last slide, the affinity gives you the bullet point and what are the important sub points under them, but how they are related would basically come out when you do the relations diagram. The basic steps in relations diagrams are: write a statement defining the issue that the relations diagram will explore, what you want to basically analyze, what are the relationship, brainstorm the ideas about the issue and write them on cards and notes. So, this is the second stage, now you go into the depth and basically try to find out what are the issues. Place one idea at a time. So, initially in the brainstorming sessions you have all the ideas and the subgroups or the sub ideas. Now, you pick up one of them and basically go into the depth, and once you have basically analyzed all of them separately, then you try to combine that what is the relationship between them, what affects which one, and how to what level the cause and effect concept can be found out. Place one idea at a time. As I was standing on the work surface and ask, is this idea related to others? If not, does it stand alone, or if they are related, what is the relationship between them? For each idea ask, does this idea cause and influence any other idea? If it does, then draw the arrows in which directions the arrows are flowing and try to find out what is the quantum of influence these ideas or the subgroups have amongst themselves. Analyze the diagram and then basically make a judgment based on both the brainstorming as well as the data which you are collecting from the quantitative point of view. So, say for example, I am giving us a very simple example of a relations diagram. So, for this is basically issues around the computer replacement project, and once you do that, so this bullet points which you see, I am using the word bullet point, but this the rectangles which you see are the main ideas, or they may be subgroups, may the ideas which is basically affecting the overall the concept of statistical process control. So, once these ideas are linked together, you will understand the linkages which is shown by the arrows would give you to what degree they are related. Obviously, the degree of relationship would come out later apart from the brainstorming and the quantitative techniques being utilized, but as of now, when you do the brainstorming session, do the relations diagram, it will give you that there is some linkages between these bullet points of the ideas which need to be considered on a serious note. So, you have basically the ideas I am just reading out. There is computer replacement project is there. So, there may be higher scores of customer service are there, there would be basically the services interruptions which are an issue, there would be staff increase or decrease in an issue, you need to train the operators, you need to train the users. So, if all of them are related, you basically try to find out that to what degree they are affecting each other. So, the tree diagram, which is the third one, is the tree diagram starts with one item that branches into two or more, and it continues doing that, each of which may branch out into two or more. So, basically it is a tree diagram or a hierarchy of importance, such that you are starting from the most important one and they are basically going down into the depth as you go down into the primary, the tertiary, the and so on and so forth, gives you idea that how linkages are there and what are the different important points you need to consider. It is used to break down broad categories into finer and finer levels of detail and information. So, the more in depth you go, like primary, secondary, tertiary and so on and so forth, they would give you the detailed information as you go down the table or the tree. When to use a tree diagram? When developing actions to carry out a solution or other plan, when probing for root cause of a problem, then you need to find out that what is the important factor which is affecting this whole problem. When evaluating implementation issues for several potential solutions are there, you basically break down all of them into their subgroups and then basically try to see them on a micro level, what are the important factors based on which you can take a decision. To continue the tree diagram, this is a procedure for the tree diagram is develop a statement of the goal or an idea or a project or a problem or whatever is being studied. So, that basically becomes the main node. Then you ask questions that will lead you to the next level of the details. So, say for example, I am finding that cost is an issue in the shop floor 1. So, once I have the idea that I need to basically concentrate on the cost, then I would basically go into the second level and it may come out that, say for example, cost is coming out because the temperatures are very high, hence the air conditioning costs running them is very high. Or maybe say for example, there are a huge amount of dust particles, hence you have to use a very special machine which may not be required if you are able to utilize some different type of air conditioning machine. Or maybe say for example, the CNC machine is poor, its capability is low, it is old, so you need to replace it. So, obviously it means the amount of wastages which is coming out from the CNC machine is very high. So, in this way you break them up and then go to the secondary level and the tertiary level in order to understand the idea based on which you are trying to proceed. So, for the example which I gave for the cost, you will basically break down into more finer levels in order to find out what the cost implications are. So, you ask yourself, do a necessary and sufficient check for the levels and basically go down the level in order to understand in depth. Each of the new idea statements now become the subject which is a goal and becomes the objective based on which you will go into the next level. So, say for example, you have a level which is the main idea which we are trying to consider, which is a cost, and cost have different implications. It may be due to the CNC machine, it may be due to the electricity usage, it may be, say for example, raw materials are not right and all these things. So, once you consider this as the main goal, say for example, the electricity cost, so you will basically go into the secondary level, it will again have different implications on the cost structure, and this way you will go down to the next the tertiary level and continue doing this such that you have the overall idea how the cost structure for this main idea which we are discussing of the cost structure can be analyzed. So, continuing this, let me read. Continue to turn each new idea into a subject statement and repeat the process. Do a necessary and sufficient check for the entire diagram and see this is a logical sequence how the idea has been explored. So, this is one. So, the diagram which I just showed you in the last slide was done in a horizontal manner, and in this case is basically the tree diagram is given in a vertical manner. In such sense, the trees are moving from my left to the right, and in the other diagram which I showed to you just a few seconds back, it was basically coming from the top to the bottom. So, here is a tree diagram, and it gives you the improved academic performance you want to analyze for any academic institutes. So, the main important ideas that which are coming out is as stated in this diagram, it would be academic achievement, college admissions, there would be a lack of indicator how the college admissions could be done, how the ranking of the colleges can be done, and so on and so forth. So, basically it will go to the secondary level, tertiary level, and you basically try to analyze each of them at the lowest level and then collate all the information till you reach the main idea based on which you have started this tree diagram. Now, coming to the matrix diagram and the matrix diagram concept. The matrix diagram shows the relationship between 2, 3, 4 or such groups of information. The strength of relationship and the role played or the interrelationship between the so called the groups would be important in order to analyze the matrix diagram. So, when to use matrix diagram? So, here is basically I am considering the examples. One of the matrix diagram concept can be expressed as L shaped, one is the T shaped, one is the Y shaped, one is the C shaped, one is the X shaped, and one is the roof shaped. So, in this case you can analyze in the L shape you can consider 2 groups, while in the X shape you can consider 4 groups. So, if you see that how the relationship can be done for the L shape would be either basically between a relationship between A and B. So, basically you are trying to understand the L shaped as this, and you will put all the set of informations or all the groups at the so called 2 nodes which I have hashed here, and that will give you what is the relationship between them. In the T shape you basically you have 3 groups, because for the T there will be one set of group here, one set of group here, another set of group here, and say for example for the X group it mentions 4 groups. So, there would be one set of groups here, second here, third here, and fourth here. So, basically you will try to go into the depth in the so called matrix not the matrix notation, the matrix diagram, in order to understand that how they can be grouped into different groups or collated into different groups in order to make in order to understand that how the relationship between the groups can be analyzed. So, in the L shaped matrix, here I am just given an example. So, here for the example when you are considering the tree diagram, the cause and effect, just few slides back. So, the main important points to be analyzed is the purity, trace of materials, parts per million, then viscosity, color, and all these things which are there. So, once you analyze, say for example, you have the customer requirements for different customers. So, they are given like customer D, M, R, T are given, and you understand and write them along the row, and along the column you have all the information from one particular customer. So, that at one go in a matrix formation gives you the relationship between the so called customers and their corresponding variable points or the group points on which you are going to analyze the overall problem. It is basically a matrix diagram. In the T matrix, you basically have the products, customers, and manufacturing locations, and they are analyzed like in the first part. On the upper half, you have the plants at different locations, which are Texas, Mississippi, Alabama, and Arkansas. And then for different type of models, model A, B, C, you basically get the informations that how they are placed. And then you go into the different type of companies, which is JIC Corporation, Arlo, Lyle, and Time. So, they would give you the set of information for model A, B, C, D in this way. So, in the T1 you would basically be able to combine the models which are shown where I am hovering my pen here in such a way that you are able to basically analyze two different sets of informations at one go, such that they will give you collectively a sort of information which can be analyzed on a micro level also. Micro level means plant location as well as the type of companies which are there for this example. In the Y matrix notation, it looks, if you look at this diagram along, so technically it should be, if you are able to do that, it will be in 3 dimension one. So, along one direction you have the customer requirements which are on daily. So, what are the points? So, they can be different subcategories also, like where I am, how I am drawing this lines parallel to the customer requirements. So, they can be the points related to the customer can be on time delivery, product availability, it can be cost also, it can be, say for example, after sales service. So, all these things would be clubbed together layer by layer on one side, where the main emphasis is customer requirement. Then would be who are the departments involved, it can be distribution, purchase, planning, order, manufacturing, vendor, sales, and all these things can be clubbed in the other direction. And then there would be internal processes, ideas and matrix would be production capability, inventory levels, order levels, carrier performance, and so on and so forth. So, once you have them, you will basically try to club them and try to find out what is the level of importance. So, where I am now circling my this pen is actually this gives you that you are trying to basically club them or try to categorize them depending on different levels of importance. So, here the level of importance have been drawn by a diagram, where the primary relationship is given by these two concentric circles, the secondary relationship is given by this so called square or a circle, and the minor relationship is basically given by a triangle. So, you can subdivide it into more subcategories also in order to understand the overall importance in much greater details. So, once you have that, you can basically combine these 3 bullet points or the ideas, which is basically customer requirements. It can be something else also, but for this example is the customer requirement, the department involved, and the internal process matrix are analyzed on each subcategory, such that you are able to give a set of importance between the subcategories based on the fact that what is the relationship, whether it is primary, secondary or minor. In the arrow diagram, it shows the required order of tasks in a project or process in a logical sequence. It can be used for determining the best schedule for the entire project, and based on which you can take a decision. Potential scheduling and resource problems and the solutions are also available using this arrow diagram concept. It basically calculates the critical path of the project. So, if people are aware of critical path method and the project evaluation review method, PERT or JERT or QJERT, so they can be analyzed in order to understand that what is the relationship when you do the arrow diagram. When to use the arrow diagram? When scheduling and monitoring tasks within a complex project or process with interrelated tasks and resources. So, what are the relationship between the precedence and the work which are going to come up later, whether the number of days of work or number of days such cushions are required between two different jobs, whether they are interlooping, all these things need to be analyzed. When you know the steps of the project or the processes, their sequences and how each sequence takes place, what is the operations between them, whether their resource constraints are there, whether the completion of the project based on the fact that I am basically drawn the part of the CPM from the project is important, all things can be analyzed. When project scheduling is critical with serious consequence for completing the project late or significant advantages of completing the work on time, so those should also be analyzed. So, if there are some penalties for overflowing the work that you are not able to finish the work right on time. So, if those things are there, you need to basically analyze them and draw the arrow diagram in order to understand the overall things which are very important from the total quality management or the statistical process control point of view. So, with this I will end this 12th lecture and then again start the 13th lecture, continuing with the concept of SPC and the TQM concept. Have a nice day. Thank you.